Assalamualaikum, my name is Norizati Norizan and I am from Bachelor of Electrical Engineering with Honours at University Malaysia Perlis. Today I present about my final year project, which is impact of circuit breaker reclosing on transient recovery voltage in high voltage networks. The reclosing is the process of re-energizing a power line either manually or automatically following a fault clearance, frequently after a short width. Many faults are temporary and can resolve themselves in a short amount of time, such as those caused on by lightning or brief contact with ecosystem. When the circuit breaker cuts off a fault current, the energy exchange between the system inductive and capacitive components produce a high-frequency oscillating voltage known as transient recovery voltage. Transient recovery voltage can exhibit high magnitudes and steep voltage gradients that stress the circuit breaker's insulation. The objective for this project is to analyze the impact of circuit breaker reclosing operation on transient recovery voltage in high voltage network, and then to evaluate the various reclosing schemes and propose strategies to minimize the adverse effect of transient recovery voltage. This project tools is using ATPDraw software. The ATPDraw features interactivity to work with components such as inductors, capacitors, circuit breakers, and source, enabling a friendly graphical interface for making, simulating, and analyzing electrical circuits, especially for transient studies. The simulation models here shows the circuit breaker 1 and circuit breaker 2 connected by the transmission line. The parameter for the circuit breaker 1 is set here. And the output will be current and voltage. Meanwhile, the circuit breaker 2 parameter is set at close 0.02 second. The switch open is 0.04 second and reclose back at 0.06 seconds. And then we run the simulation and then run plot to see the waveform. As we can see here, this is the waveform that came from the simulation models. First plot shows the voltage at source in sinusoidal form. This is the voltage at receiving end, 0.02 second and 0.04 second indicates that the switch is open at 0.02 until 0.04 second and then reclose back at 0.06 second. The transient happen when the reclosing condition. This is the comparison for the current and voltage when reclosed. As we can see here, this is the data when the switching circuit breaker reclose at 0.06. The current kindly increase and spike because of the transient effect. The tools constraint when using this ATPDraw is no built-in relay or renewable energy models, requiring users to manually create logic for protection and inverter systems. Next, output visualization is limited depending on external tools like plot XY or scope view for waveform analysis. As we can see before, the waveform only shows 4 plots. And the last one is steep learning curve with limited documentation and no commercial support, making it challenging for beginners to use it. For the conclusion of this project, the ATP is a powerful tool for electromagnetic transient analysis in power system. Despite its capabilities, it has significant usability and modeling limitations, especially for modern power systems. Next is ideal for high-frequency switching and fault studies, especially in transmission system. The last one is requires strong technical knowledge, making it more suitable for experienced users and researchers. That's all from me. Thank you.